Hey guys, it's Miss Montrose. I hope you guys are doing well. This week on your packet, you are going to have a couple of things that are going to be new to you. So I decided to make a couple of more instructional videos to help you out on that. One of the things that you guys are going to see in the extra stuff that I added in your packet is multiplying decimals. Okay. I know we have added and subtracted decimals, and we've done all our fraction unit stuff, added and subtracted fractions, multiplied fractions, but the thing that we have not done this year is multiplying and dividing decimals. And if we were back in school, this is technically what we'd probably be starting either this week or next week. So let's go ahead and jump into this with this new instructional video. Now remember, we can think about multiplying as groups of or sets of. Okay? And when we multiply a whole number times a fraction, we can also think about groups of or sets of. So let's look at the equation above. I have 3 times 6/10. Well, 3 times 6/10 also means that I have 3 sets of the 6/10. Okay, so remember, anytime we are multiplying either a decimal or a fraction by a whole number, we can always use the repeated addition strategy. So in this case, I have 3 times 6/10, or 3 sets of 1/10. Well, that's the same thing as saying that I have one set of 6/10 and another set of a 6/10 and another set of a 6/10, in which I can add all together because I can use the repeated addition strategy. Well, I know that if I'm adding and subtracting decimals, my decimal needs to be brought down. And if I look at everything in my tenths place, I'm going to go ahead and add that first. 6 plus 6 plus 6 is 18. So I'm going to put my 8 here, carry my 1. Okay, well, I know that, now let's go ahead and add my 1's place. I know that 1 plus 0 plus 0 plus 0 is the same thing as 1. Okay, so 3 sets of 6/10, or 3 times 6/10 is 1 and 8/10. Now let's say I want to multiply a decimal times a decimal. Okay. So let's see what that looks like. Let's say that I have 2/10 times 9/10. Okay. Well, I'm not multiplying a decimal times a whole number. I'm multiplying a decimal times a decimal. So in this case, because I don't have a whole number set of a decimal, I can't just do repeated addition. And if we were back in school, we would be working with a ton of decimal counters, and we would be working with 10 frames. But in this case, since we're out of school, I'm just going to go ahead and jump to standard algorithm because I want to give everyone the same lesson, and I want not everyone is able to have access to manipulatives. So I want to make sure that I'm teaching everyone at the same pace and the same way. So when we're looking at a decimal times a decimal, we technically want to take these decimals and we want to make them whole numbers. Now you're probably thinking to yourself, Miss Montrose, how do I make a decimal a whole number? I know that all whole numbers in the entire world, it's part of a decimal, but I just don't indicate that decimal. So if I look at the whole number 4, I know that it's the same thing as 4.0. Okay? Or if I look at 10, I know that 10 is the same thing as 10.0. Just in everyday life, we don't discuss how it represents 0.0, and we just say 4 and 10 because there's no reason to talk about a decimal when there's nothing in the tenths place. Same thing with larger numbers. If we look at the number 279, that's still the same thing as 279.0. So in all reality, every single whole number has a decimal in it. We just don't talk about the decimal if there's nothing in our decimal place value. So let's take that knowledge and let's talk about 2/10 versus multiplied by 9/10. Well, what I can do with those decimals is I can go ahead and shift them to the right to put them on the end. Do the same thing with your 9/10. Shift your decimal over to the right, making it whole numbers. Well, if my whole number is all the way to the right, well, instead of 2/10 times 9/10, it now becomes 2 times 9. Okay. But don't forget that you move those, and I'll tell you why towards the end. Okay, well, I know that 2 times 9 is the same thing as 18. Okay, well, I know that 2 times 9 is 18, but what we were doing was trying to find 2/10 times 9/10 and what that equaled. Well, all we've done so far is moving our decimals to the right to make them whole numbers and then multiplying to find our answer. But we're not quite finished yet. Remember a second ago that I said do not ignore the fact that we had to move our decimals. And here's the reason why. Once you have your answer 18, I'm going to put that decimal back on the end because remember, any whole number has an invisible decimal in the end. We just don't always use it unless there's something in the decimal place value. Okay, let me erase that so you don't confuse yourself. Okay, so we put our decimal back on the end. Well, let's talk about how many times we moved our decimal in our equation. All right, in the number 2/10, I moved my decimal over 1 time to make it a whole number. And in the decimal 9/10, I also moved that decimal over 1 time to make it a whole number. So in my equation, 2/10 times 9/10, I moved my decimal over a total of 2 times. Now, if we take the number 18, and we already placed our decimal on the end of it, if we take our number 18 and we moved it in our equation 2/10 times 9/10, if we moved it to the right a total of 2 times, well, let's just do the opposite with our answer. Let's move our decimal to the left a total of 2 times. If I take my decimal, move it 1 space and then another space, I have moved a total of 2 times. Okay. Now, instead of my decimal being on the end and it being 18, my decimal has now become 1800ths. Okay. So 2/10 times 9/10 equals 1800ths. Let's look at another example. All right, let's look at the example of 1 4800ths times 1/10. Okay, and again, we can't do repeated addition in this one because I don't have a total number or I don't have a whole number set of something. Okay, so I'm going to use the standard algorithm with this. And again, I apologize that we're not able to explore with the manipulatives and really dig deep into the standard. But I figured at least showing you standard algorithm will at least prepare you a little bit for 6th grade because this is something you're going to have to do in 6th grade as well. All right, so again, just like we did above, we are going to move our decimals to the right. If I look at 1 4800ths, well, I can't just move it over 1 time because it's not putting it on the end. It's putting it in the middle of the 4 and 8. My goal is to put it on the very end to make it a whole number. So instead of 1 4800ths, I moved my decimal all the way to the right, and now I have 148. Times, in this case, 1/10, I only have 1 decimal place value that I have to move it over or shift it over to the right to make it a whole number. And now that becomes 1. Well, you guys don't really have to set this up because I know that 148 times 1 is still 148. Okay, but in this case, in my first number, 1 4800ths, remember you have to keep track of how many times you moved it total. In this case, I move it over a total of 2 times, and in the 1/10, I moved it over a total of 1 time. So in this case, I moved it a total of 3 times. Well, 148 times 1 is 148. If I put that decimal on the end and move it over back to the left a total of 3 times. 1, 2, 3. So 1 4800ths times 1/10 is 148 thousandths. All right, let's look at one that is a little tougher. Okay. All right, let's look at 5 1600ths times 800ths. And I'm sorry this is looking a little bigger, guys. My Apple Pencil just died, so I'm trying to use my finger now, and it's a little harder. Just one of the perks of teaching long distance is that technology just sometimes just turns off. So we're going to try to make the best of it and finish up this video. All right, so 5 1600ths times 8/10. Well, again, the first thing I want to do is move my decimal over to make it a whole number. So 5 1600ths now becomes 516 times 8/10 now becomes 8. Okay, and you guys can use any type of strategy you want to when you're setting these up. You can use standard algorithm, you can use box method, you can use partial quotients. In this case, I am going to use the standard algorithm and go ahead and solve it. So it now becomes 516 times 8. Well, I know that 6 times 8 is 48. Carry my 4. 8 times 1 is 8, plus 4 is 12. Carry my 1. 8 times 5 is 40, plus 1 is 41. Okay, and remember, we have to keep count of how many times we moved our decimal to begin with. So in this case, I moved in 5 and 1600ths, I moved it 2 times, and in 8/10ths, I moved it 1 time, for a total of 3 times. Okay, so I want, with my product, take my decimal, which is going to be at the very end, remember it's just invisible, and move it back to the left for 3 times. So 1, 2, 3. So now my decimal is in between my 4 and my 1. So now my answer of 5 and 1600ths times 8/10ths is now 4 and 128 thousandths. Right? And there's one more that I'm going to show you, but I'm going to use the partial products strategy instead to solve this. Okay? And I'm going to take, I don't know, let's take 12 and 9/10ths times, let's do 4700ths. Okay, and again, the first thing I want to do is move my decimal to the right to make it a whole number. So move it over to the right, move it over to the right, and in this case, I moved this one over once, I moved that one over 2 times for a total of 3 times, and we'll get back to that in a second. So now let's go ahead and set it up to 129 times 47. And again, you guys can use standard algorithm. In this case, I'm going to use partial quotients. Okay, so I'm going to solve it just like I would use partial quotients. All right, so let's start with our ones place value. 9 times 7 is 63. 7 times 20 is 140. Okay. 7 times 10 is 70. Oops. Messed that up. Let me go back and fix that for you guys. Got a little ahead of myself. 7 times 10 is 70. Okay. And I've done all of my ones place values, so let's move on to my tens. I have 4 tens, which is 40. So 40 times 9 is 360, plus 40 times 20 is 800, and then 40 times 100 is 4,000. Okay. Now what I want to do is go ahead and add all of those values up. I'm going to kind of move this over to the side so I have room. Okay, so then I have 4,000 plus 800 plus 360, and I'm sorry guys, this is a little sloppy. I'm trying the best I can with my hands. And then remember, when we were doing our multiplication unit, we always went in order from greatest to least, So then 140, and then plus 70, and then plus 63. So I have all my numbers. We're doing partial quotient still. So add all my ones place value. 3, 6 plus 4 is 10, plus 7 is 17, plus 6 is 23. 8 plus 2 is 10, plus 3 is 13, plus 1 is 14. And then carry my 1, and then 5. All right, now what I'm going to do, because I ran out of room, because I'm having to write with my finger now, I'm going to rewrite the equation. So I had 12 and 9/10ths times 4700ths. Okay, so let me get my marker back. 12 and 9/10ths times 4700ths. Okay, and when I made those whole numbers and I multiplied them, I got 5,433. Right, so 5,433. But don't forget that when I made those whole numbers, I moved my decimal a total of 3 times. So the very last step that I want to do is put my decimal on the end of that product and move it back or shift it back to the left 3 times. 1, 2, 3. So my answer is 5 and 433 thousandths. Okay. So again, with any of these, you can use any strategy you want to. Just remember that you only need to move the decimal when we're multiplying. When we're adding and subtracting, you'll do just like normal. Well, you'll bring the decimal down, just like we did in last week's packet when you guys practiced that a little bit. And I also just want to point out how proud I am of y'all. I know that this distance learning stuff has not been normal, and I know that you guys are outside your comfort zone, and you guys are trying to do, you and your parents are trying to do the best you can to get this work done. And I just want to commend you on that and let you know that you guys are doing a great job. For the students that I have talked to, I'm seeing some really, really great things. So just keep up the good work, and hopefully we will be reunited soon. All right, talk to you later. Bye.